All throughout this unit, you guys have been, I'd either give you a proportion to solve, or you guys have been setting up your own proportion to solve. All right, so I'm just going to blow up my A over B equals C over D proportion here on the screen for you. And what you guys have done is, hey, if you want to solve a proportion, you cross multiply the darn thing, right? Cross multiply. And that's the term you guys have been using, is cross multiplying. I want to use some different mathematical terms today. When you guys have been going cross multiplying like this, when I multiply my A and my D value, what you guys are actually multiplying in the proportion are values called the extremes. All right, you're actually, when you multiply from top left to bottom right, those two values that are there, whether they're numbers or variables, are called the extremes in a proportion. Okay, those are called the extremes. And when you multiply from bottom left to top right, you are multiplying values which in mathematics we refer to as the means. All right, the means of a proportion. So the extremes are as you go down from left to right, and the means are as I go up left to right. Okay, so you got extremes and means. And you set them equal to each other after you're done multiplying, right? You set them equal, which leads us to the last theorem for this unit. I got a little trivia question for you honors kids, a math trivia question. Let's see who's got it. In math, when I add two numbers, it's called the sum. The answer is called the sum. When I subtract two numbers, the answer is called the difference. When I divide two numbers, the answer is called the quotient. How about when I multiply two numbers? Like I am right now. When I multiply two numbers, what do I usually call the answer in mathematics?
The product?
The product, yes, it is called the product. The answer when you multiply two numbers is called the product, which leads me to my theorem for today, which is the product of the means. So when I multiply those two numbers, the means, the product of the means is equal to the product of the extremes. In a nutshell, cross multiplying, right? I multiply, set it equal, multiply. Product of the means equals product of my extremes. Just got to know what the extremes are and where the means are located. And that's what we're going to do today. 2 days ago, we proved triangles similar, and you guys don't have to copy this down. We proved triangles similar in a proof by angle. Yesterday we said, okay, triangles are similar. That means their corresponding sides are proportional. AB over DE equals, let's say, BC over EF by CSSTP. And then today we're going to take that one step further and actually say, when I multiply side AB times side EF, it is the same product as if I multiply DE times side BC, because the product of the means equals product of the extremes. So everyone see the 3 steps here. It's a 3-step process to get the means and extremes equal. Prove the triangle's similar, show the sides are in the same proportion, and then we'll show the means and extremes are equal. All right, proof number 1. Don't write anything, please. Don't mark anything. Just look right at the proof statement for me. Look right at your proof statement. Do you see I'm trying to show a product of 2 sides is equal to a product of another 2 sides? That's what I'm asking for. So right away, I know this is going to be means and extremes if you're asking me to multiply sides together. Multiplying sides together, it's got to be means and extremes. All right, before I even sniff means and extremes, I got to prove 2 triangles similar. That's the only way I get to means and extremes being equal. Prove a pair of triangles similar. Just like yesterday, the diagram's got too many triangles for me to just guess which 2 I'm going to prove similar. So you guys take a minute right now. Look at your proof statement. I have 4 sides in that proof statement. 4. Use those 4 sides to determine what 2 triangles you're going to prove similar. Go ahead. And then I'll ask somebody which two. Use those 4 sides to figure out what 2 triangles are going to be proved similar here. Because that's my first step. Prove 2 triangles similar before I get to means and extremes. Whew. All right, let's do this. What 2 triangles do I need to prove similar here to get this ball rolling? Oh, there we go. St. John, which 2 triangles?
AET and ARD.
AET and ARD. Okay, I have a problem with those because isn't DT part of one of the sides in the proof statement? And the 2 triangles you gave me do not include DT at all.
Wait, so is it ARD and ADT?
Okay, I agree with ADT. ADT, because that's got DT in it and it's got AD in it. So I have DT and AD taken care of. Now I'm looking for a triangle that contains ER and TE in the same triangle. And I don't think that's going to be AET.
ERT.
Okay, ERT, there we go. All right, guys, all 4 sides have to be represented in your triangle. All 4 sides have to be represented. Okay, everybody good? I'm picking those 2 triangles. All right, now we got to get them similar. And you guys know in a proof anyway, in a proof, the only way I get them similar is by angle. I know these 2 sides are equal, and I gave you 2 right angles, TER, and I gave you ADT. All right, let's get them similar, because again, this is a 3-step process to get to the means and extremes to be equal. 3-step process. Get the triangles similar first. All right, give me a pair of angles then. Anybody see a pair of angles? Let's roll 5. Hayden, give me a pair of angles that should be congruent based on these givens.
Angle E and angle D.
Okay.
Angle RET and angle ADT.
Thank you for getting more specific for me. Yes, right off the bat, angle RET is congruent congruent to angle ADT, because I gave you that they're right angles and we know all right angles are congruent. All right, there's one pair. You didn't even have to tell me they were right angles there. I gave it to you. So 1 pair down. Where's the other pair of angles going to come from? Use the given we haven't used yet. We already used the right angles. What about this isosceles business? 1, 2, here we go. Lucas, what other pair of angles must be equal then?
Sorry, won't let me unmute. Angle ETR and angle DAT.
Why is that?
Because they're in similar triangles.
The triangles aren't similar though. That's what we're trying to prove.
Oh, okay. Sorry.
I'm trying to. The main way is angle. I already have 1 pair of angles from the right angles. Now I'm searching for another pair of congruent angles in these 2 that I've highlighted.
Angle ERT and angle ATD, because in isosceles triangle, base angles are congruent.
Okay, here we go. Angle R is congruent to angle ATD in a triangle. Congruent angles are across from congruent sides. All right, perfect. No issues there getting both pairs of angles. Questions? All right, now they're similar, so let's make sure we get that statement in there. Make sure all angles match up correctly when you write it out, and you put the similar symbol, the tilde, not the congruent sign. So triangle RET is similar to, if I go RET, I better go ADT. Ooh, no, RET Act like you've been there. TATDA. By angle. All right. Again, I can't jump right to means and extremes unless I have a proportion where I can cross multiply. So it's just like we did yesterday. Now that the triangles are similar, corresponding sides are in proportion. But you have to create that proportion now. Yesterday, yeah, you just copied the darn proof statement down and you were good to go. Now I got to create my own correct proportion. Look at the proof statement to help you guys out. Remember, ER and AD have to cross multiply with each other. So if I put ER in this first spot on the top left, AD has to go on the bottom right. All right, ER and AD, because that's the only way I'm going to cross multiply it. So those become my extremes right there, ER and AD. The other two, TE and DT, become my means. Is this the only correct proportion? No. It all depends on where you put ER to start the proportion. ER and AD have to be diagonal from each other because remember, you're going to cross multiply. And then this is CSSTP from yesterday. Corresponding sides, similar triangles are proportional. And then here's where we're taking it. Go ahead, question?
Why is it ER over TE? Because those are both ones in the same triangle.
Again, Sophia, this is one way to write it. If you want me to write ER over DT, I'll do that too.
But either one works.
But any way works. I know that's the way I've set up my proportions usually, but all I'm concerned right now in my proof is I need to make sure ER and AD are right here, are diagonal from each other so I can cross multiply them. Look, if you want me, I can do this. This is also acceptable. ER over DT equals, let's see, TE over AD. That's also acceptable. Again, as long as I'm cross multiplying ER and AD and TE and DT, the proportion is going to be correct.
I was just thinking of that because in the past we set up a proportion
Yep.
they were usually.
You're 100% correct. When we did the algebra questions, that's how I usually set up my proportions. Correct. Now, all I'm worried in this proof here, all I'm worried about is making sure I cross multiply what's in the proof statement. And now here's our extra step today. Setting the means and extremes equal to each other. ER times AD equals TE times DT. Product of the means equals product of the extremes. Questions there? It is a 3-step process to get to the means and extremes to be equal. You guys, basically, I've been building to this level for the last 2 days with you. We proved triangles similar on the first day of proofs. Then I introduced CSSTP yesterday, and here's our final step, getting the means and extremes equal. All right, we got one more, and then you guys can spend the rest of the time working on the assignment. You guys can see in the proof statement, I'm proving the product of a pair of sides is equal to the product of another pair of sides. So means and extremes. So take a minute, use those 4 sides and determine which 2 triangles are going to need to be proved similar here. Which 2 sides are going to be needed to prove similar. All right. Hopefully I gave you guys enough time. Which two triangles here contain all four sides? Which two triangles contain all four sides? Here we go. Top of the page. Vinny, what do you got? Which two triangles am I going to try to prove similar?
Triangle CRQ and triangle RPQ.
RPQ. So you want this one right there. All right. Let's see. QC is good. QP, AQ. Here's a problem though, Vinny. I don't have any, the two triangles you gave me, neither one of them have AQ as a side, and that's in my proof statement. Right? I don't have AQ. I don't have AQ as a full side in either of those triangles. I agree with your big triangle, CRQ. I agree with that, Vinny, because that's got your QC in it, and it's got your, let's see, AQ, nope, QP, nope, CR, and it's got CR in it. So what I need now, Vinny, is a triangle that's got QP and AQ as full sides.
Triangle AQP.
There you go. This one that matches up right on top of it there. All right, so there are my two triangles. You guys will get more practice in that tonight, trying to find them. All right, so here we go. Only given I provided you was, hey, this thing's a parallelogram. And you guys need to find two pairs of angles for me because we know we got to get them similar first. So, yes, I know. That was something we did last unit. Anything's fair game through the entire year, including properties of a parallelogram. All right. Oh, and do you see, using your properties from last unit, do you see any angles that should be congruent in those two triangles?
Angle SRQ and angle APQ.
Good job. Excellent. There you go. Because Owen is remembering the property of a parallelogram that says opposite angles congruent. So angle SRQ congruent to angle QPA. You can call it QPS if you prefer. Parallelogram implies opposite angles congruent. Good job, Owen. Good job. Yeah. I like that. All right, perfect. There's one pair of angles, need another pair. And again, you don't have really much to go off the givens. It's still a parallelogram, so I'm assuming I got to bust out another property to get another two pair of angles. Another pair, anyway, of angles. So take a look. They have to be angles inside those two triangles. Don't give me angles in another triangle. Do we see another pair that could possibly be congruent? All right, what do we think? Here we go. Hayden, going back to you. Any other angles in these triangles have to be congruent? I would only focus on the angles in those triangles only. So there's two left in each. And I know they have to be congruent. One's got to be congruent to one and the other's got to be congruent to the other because that's the way this works. So we just got to figure out which pairs are equal. And remember, it's a parallelogram.
Is it angle?
What do you know about opposite sides of a parallelogram?
They're congruent and parallel.
Okay, let's take that parallel property there. Opposite sides are parallel, which usually means we got some special types of angles working. Most likely alternate interior. Do you see any alternate interior angles with any of the opposite sides of the parallelogram here?
Angle A and angle RQA.
Okay, I like RQA. I don't like it that you called that first one angle A. Can you be more specific?
Angle QAP.
Okay, yep. There's one set right there. Okay, there's one set. I'm going to do the proof that way because Hayden gave it to me. Some of you, if I called on you, I don't know how many of you would have gave me angle C congruent to angle BQP. That is also another correct pair you could prove congruent because it is alternate interior. And I'll show you, you guys that want to do it that way, that's fine. I'll show you how to prove C and BQP at the end of this proof. All right, but for now, I'll stick with Hayden's too. They're not congruent yet. Those are not congruent until you tell me the lines are parallel. RQ, right now, RQ, because it's a parallelogram, is only parallel to SP. Only parallel to SP. Parallelogram implies opposite sides parallel. But I don't need all, take a look at your diagram. I don't need all of side SP, do I? Because angle BAP is only formed on AP. What I need is RQ parallel to AP. Anybody remember that theorem when I introduced it to you? We usually use the other theorem that's associated with it, but we got to use this one here when I get the smaller version of it instead of the longer one.
Segments of parallel lines are parallel.
Okay, I'll take segments. Yeah, that's fine. I'll take segments. I think I used the word parts instead, but segments are fine. Okay. Then you could tell me the alternate interior angles are equal. All right, so the ones Hayden just gave me here, RQB, RQB, and BAP. And again, you can name them differently as long as it's the same angle we're talking about. Parallel lines imply alternate interior angles congruent. All right?
Why would you have to include the parts of parallel lines part?
Here's what I'm looking at right here. Let me get a big highlighter going. I'm seeing this angle right here is on RQ, right?
Mm-hmm.
And then as I continue drawing the other angle, that angle's only on AP, not SP. So that's why I'm saying, oh, that angle right there is formed by QA and AP, not QA and SP. So that's why I need to show you RQ is parallel to AP instead of SP. Because that's just how that angle's formed. Okay? Before I finish the proof here with you, let me go back to this one. Some of you saw that angle C was congruent to BQP because it was alternate interior. What would be the steps that would lead to that? You would first tell me RS parallel to QP. The other pair of opposite sides are parallel. Then, just like I was discussing with Maeve, angle C is not formed by RS. It's formed by RC. So I would need to tell you that RC is also parallel to QP, but that would be by extensions of parallel lines are parallel. Okay, so that's how you would get to those two angles to be equal. You'd have to use extensions instead. Okay, let's finish this proof now. We got the triangles are similar. Let's see. I'll go QAP first. QAP is similar. Let's see, if I go Q, I got to go C. If I go A, I got to go back to Q, CQR. Angle. Triangles are similar. Corresponding sides are proportional. I'm going to ask somebody right now to come up with a good proportion here. Not the only one, but a good one. Look back at your proof statement. You got to make sure you got your means and extremes in the right spot so you multiply them. All right, give me a good proportion that you set up here. 17. Maeve, go ahead. You got a good proportion where I cross multiply the correct parts.
Q C on the top,
Yeah.
AQ on the bottom, then CR and QP.
Okay, I just got to go up and check here. Am I multiplying QC and QP? Yep, you're good. CSSTP. And then the last step now, the new step today, multiplying your extremes and your means together and saying their products are equal. Questions from you guys at all? Any questions? Going?
So this just means that any of the other the proofs tonight might be like a little on the long side, but only because you need 3 steps to get to that part.
Correct. And they may be a little bit trickier than the last 2 nights because as you saw from these last 2 proofs, it might be a little difficult to find the triangles you need to prove similar as well. All right, because I think both diagrams tonight, multiple triangles are in the diagram. So you guys got to take a deep breath and use your proof statement to figure out what triangles I'm trying to prove. Similar. But yes, they will be a little bit longer. All right, guys, go ahead. Get going. You guys I'm here too if you have questions. If you want to make sure you have the correct triangles or not, well, you guys can figure that. You can look at the answer key. If you want to start with the algebra problem instead, I didn't do any algebra questions in class today because I've done enough with you. It's time to let you go on your own and try some.